Hi. This time we're going to compute the zodiac sign approximately. We're given two numbers, one for the month and one for the day. It's given as a table on the problem description website, but I've imported it here. I'm not going to go into how we get it in. There are various ways to do that. But know that what we have here is a matrix representation of character vectors, which is exactly like the table is there, including some strange spaces that we really don't want. And we're going to clean all that up. So our first problem is that while the table is laid out for human consumption, it is not really very good for machine consumption. We can see that we've got 4 columns, but it's actually a database table of 2 columns, the sign and the date range. And the date range as well is formatted nicely for humans, but not really very nicely for computers. So we've got 2 columns that are actually the same column twice. Let's start by cleaning that up. So the first column and the third column belong together, and the second column and the fourth column belong together. So we're going to permute the columns of the table. Now we want to get the cells in the table that belong together to be together in sequence, because the reading order here, if we just flattened our data, is Aries, Libra, and then March 21st, and then September 23rd, and then Taurus. And that's awkward. But if we transpose our table, then the reading order has all the signs first, and then all the date ranges. Now the only problem is that we have 2 rows for each one of these, and we only want one, with, of course, 12 columns. So 2 rows and 12 columns reshapes this transposed table. And now we've got 2 rows, one with the signs and one with the date ranges. Another problem is that, strangely, this table begins from March 21st, and since we're going to look for dates in the Gregorian calendar that begins with January, then we'd want to rotate this around. So this is a -2 steps horizontal rotation of the table. So the normal rotation takes elements from the left and sticks them over on the right. Now we're doing the reverse, so that's why the negative number is 4. And now we begin with January instead. It's a table, and it's much easier to work with this data having it separately. One list of signs and one list of dates. So let's split the table into 2 vectors. And we can't actually see the dates, but they are out there to the right. And then we assign them to S and D for the signs and the date ranges. Like that. Here are the signs, and here are the date ranges. And now we can see that the signs have some trailing spaces, which we should probably get rid of immediately. So the signs, and then we're going to use a special syntax. Let's first try to remove the signs. So we want to, this is a set difference, so without, we can read it as, without from each one of them a space. And that works, this removes them, but this didn't update the variable. And we could assign it just to S, but more fun is to use something called modified assignment, which is something you see in other languages as augmented assignment. You might see things like plus equal, so you have some variable named v, and then you increment it like this, or decrement it, or have it. In APL, we allowed absolutely any function on the left. That function is given the original value on the left and this parameter, new updating value on the right, and then whatever it computes is then assigned to the variable. So in this case, our function is a derived function, which is the without each function, and then we just stick the assignment arrow over here, and then this parameter is given as right argument, and the variable's current value is given as left argument, and the result is put into that same variable. Now, this has been cleaned up. Next step is to parse the dates. We could go and parse the month names, but we actually know that there's 1 month for each, so that's just the range iota 12. That's the integers from 1 to 12. The only thing we should extract then is the day of that month, and we only want the first number in each cell because it's actually redundant information. The last day of one sign is the day before the first day of the next sign, and we're going to go with beginning dates rather than end dates. So a really nice way to do this is to use quad VFI. This means verify and fix input. And it's called verify and fix, where verify makes sure that a token is a proper number, and fix actually converts that text to a number. And so we can try this with the first one. So the first one of D, if we just run this by itself, then by default it splits on spaces. It uses them as token separators. So we can see it saw 3 tokens here. There's January, there's 20 and dash February, and then there's 18. And the verify part is on the left, and the fix part is on the right. The verify part is a Boolean mask saying that this token was invalid, this token was invalid, and this token was valid as a number. And these are the values with zeros substituted for invalid values. So we can see we only got the 18. However, we can also tell quad VFI to use one or more field separators. So we want both space and n dash as field separators. And now, if you try running this, we can see that it split it up, and we got both the values 20 and 18 out recognized as numbers, and then there was the February and the January that were considered invalid tokens. They're not actually proper numbers. And since we know exactly what kind of data we have here, this is good enough for us to parse it fully. We can then, well, we can take it one step further. We know what this mask is going to look like, so we can ignore that. And we know what this one is going to look like. So we can just go in and take the second element of the second element. And we can do that with the pick function. 2 means go into the second element of the overall structure, and then inside that, go into the second element again. And that gives us the 20. Now the only thing we need to do is wrap this in a little lambda where omega represents the argument and apply that to each of D. And that gives us our cutoff days of the month. We can make this into a matrix. So now we have a column vector or column matrix, single column. And then we can take those indices from 1 to 12 and concatenate horizontally to that matrix. And that gives us a lookup table for where the cutoff dates are. Let's call this C for cutoff. So here's our cutoff table. Okay. Now, if we have to come up with a strategy for actually finding the signs. And if you look at our table again, then we'll see that if we go and look for December here, we're going to end up with the end of the year here being Capricorn. And that's fine. That's the 12th one. But there's also a part of the beginning of the year, which is a bit of an issue. So any date before the first cutoff should really end up with Capricorn as well. One way to do this would be to add another element to our lookup table. Another one is by doing a cyclic lookup. So we could use modulus and compute the indices, but even easier is to rotate cyclically, like we did before. We rotate cyclically the whole table of signs, and then we can have indices or positions between 0 and 12. So we'll call it 0 when we are before the first cutoff date, that is from January 1st to January 19. And then we'll call it 1 when we have from January 20 and onwards, and 2 when we have that, and so on. And then we have the 12th one when we have December 22 and onwards to the end of the year. So this means that we want the Capricorn to be in front, because that's going to be the 0th step. And currently we have the signs arranged with Aquarius first. But we can do the same kind of syntax as before. We do a rotation, but rotate takes the amount on the left and the data on the right, so we need to commute or swap the arguments. -1 step. Now we have Capricorn first. So if we have 0 rotation of the signs, then we get Capricorn first. And if we pick the first one, then it becomes Capricorn. If we rotate it 1 step, that is after the first cutoff date, we get Aquarius. At 12 or 11, let's do that first, we get Sagittarius. And 12, we're back to Capricorn. So this works really nicely. We then just need to do some lookups into our table. So here's the table of cutoffs, and we have something called interval index. Interval index, it looks where do things fit with every major cell, or row in this case, being the beginning of a section. So it will look, does something belong with 120 and further, or 219 and further, and then this, the first interval here between these two is called interval 1. Before the first one is called interval 0, and then the last one defines interval 12, which is exactly what we want. So we can try it. 223, interval 2. So this works with lexicographical ordering, meaning we look at the first element and then we look at the second element, which is exactly what we want. So 223, it falls in here. That's interval number 2. And we can try it with 10 to 31, the other example case given. That's over here. Now we can try it with January 1st. You see we get a 0. So that's before the first one. So for a date like this, we can take this and rotate the signs. And then we pick the first one. The remaining step is to make this into a proper standalone function. We could put in an argument here and then wrap everything in a lambda. We could even save our parentheses by commuting the arguments of the rotation. So this is one way to state it. Or we could make a tacit definition, where that's one where we don't mention the arguments by name. Instead, we say that we bind as a fixed left argument to interval index, to the lookup. We bind this lookup table, and then we use that to rotate the signs and pick the first one. That's another way to write it. However, the reading order here with the swap arguments is not actually, we don't need to do this swapping, because we could instead write the rotation and then use the sign vector here, but make it into a constant function. So this returns the signs. It gets rotated by the interval index into the cutoffs. So this is another way that we can write it. And now we can try on each one of 223 and 1031 with the example cases. And we can try that with G as well. It's entirely equivalent. Thank you for watching.